Here we are trying to deduce oxidizing and reducing agent. To do so, we have to determine the species that are oxidized and reduced. So let's start off with figuring out the oxidation states. So the oxidation state of manganese, let's figure out the oxidation state of manganese in permanganate ion. So that's unknown, let's call that X. And the oxidation state of each oxygen is -2. We have 4 of them, so -2 times 4, that is -8. And the total oxidation state of this ion is -1. It's given here. So X would be +7. So that is the oxidation state of manganese in permanganate ion, which is +7. On the right hand side, in manganese 4 oxide, the oxidation state of manganese, let's call that as X, and we have 2 oxygens, so that would be 2 times -2, which is -4, and the total oxidation state is 0. It's a neutral molecule. So the oxidation state of manganese in manganese 4 oxide would be +4. So the net change in the oxidation state of manganese is from +7 to +4. That's a decrease in oxidation state. So now why did this oxidation state decrease? Well, it must have gained electrons. So if it gained electrons, we call that process as reduction. Right? So that's what happened to manganese. Its oxidation state decreased from +7 to +4 because it gained electrons. Now let's do the same thing with bromide ion here. So we have bromide ion here whose oxidation state is -1, and in BrO3 minus, the oxidation state of bromine is, let's call that as unknown X, and we have 3 oxygens, which is 3 times -2, that's -6, equals to the total oxidation state on this ion is -1, so X would be +5. So the oxidation state of bromine changed from -1 to +5. So that is an increase in oxidation state. So why did it increase? Well, it must have lost electrons. If it loses electrons, well, we call that process as oxidation. Right? Now, in order to remember this better, here is a mnemonic aid for you. So the mnemonic aid goes like this: Leo the lion, Leo the lion goes. This word goes has no significance. Grr, like the sound made by a lion. So what do these letters stand for? L stands for loss of electrons. L is loss of, E is electrons, and O is oxidation. Is oxidation. Similarly, the letters G, E, R, they stand for gain of, E stands for electrons again, and R stands for reduction. So this is a simple mnemonic aid to remember oxidation and reduction in terms of electrons. Now let's go back to our original question and try to figure out oxidizing and reducing agent. To do so, let's write this word equation. So here is my oxidizing agent. This is my oxidizing agent. And this is my reducing agent. So what is the connection between these two? Well, a reducing agent gives electrons. So a reducing agent gives electrons to the oxidizing agent. Now what does that mean? Well, this is losing electrons, so I can say that is being oxidized. So losing electrons, so I can call that as oxidized. And based on the information that we have before, the species that is oxidized here is Br minus. So that's being oxidized, Br minus. So that's our reducing agent. Well, what does a reducing agent do? It helps reduction or brings about reduction brings about reduction by giving electrons. Now let's figure out what the oxidizing agent is. What's happening to this oxidizing agent? Well, if you look at this equation here, it's gaining electrons. So we can say that this is the species that is reduced. Now the species that is reduced here, we are saying the manganese in the manganate ion is being reduced from +7 to +4. So the species that is reduced is MnO4 minus. So that's our oxidizing agent. So this is our oxidizing agent, and Br minus is our reducing agent. So the definition of a reducing agent is one, it could be an atom or ion that brings about reduction by giving away electrons, whereas oxidizing agent is one that brings about oxidation, and how does it bring about oxidation or support oxidation? Well, by gaining electrons.